Hello. So yeah, I will start today's coding practice. So here's today's question. So you were given an array of events where event I is start day I and end day I array. Every event I starts at start day and ends at end day. You can attend an event I at any day D where start time is smaller than D and end time is larger than D. You can do an event I at any time D where start, okay. And you can only attend one event at any time day. Okay. So the question is, so returns the maximum number of events I can attend. Okay. So, okay. So let me first start with confirming the data input and also the interface of the method I will be implementing. So in this question, I will return the maximum number of events I can. So max events I will define the function max extendable event, and the date input should be an array of events. Okay. And then I will return count. Okay. And for the date input, event is the array of start and end day. And yeah, let me quickly confirm the sanity of the date input event. So can I say start is equal or smaller than end? Yeah, okay. I will do so. Yeah, I will go with this date constraint. And also what I'm interested in that okay, I see. Okay. So if the event array is empty, so yeah, that obviously I should return 0. So it's okay. Yeah. Okay. So let me think of this question with some examples. So it's the data input is, let me think of this. So 1, 1, and 1, 2, 1, 3, and 7, 2, 4. So let me start with this example. So every day, and okay, the first event is on day 0 and day 1. Only one, okay. And the second event is on only day 1. The third event is day 1 to 3. And the fourth event is day 2 to 4. Okay. So in this case, I will be able to attend so one. Okay, so on day 0, I can attend this first one. And for day 2, oh wait, you can attend the event. So sorry, let me confirm one thing. Do I have to attend all the days for one event to be considered to be that I attended it? Yeah. Okay, so let me confirm in the LeetCode. So, oh no. So I have to attend at least one day in the event. Okay. So that being said, on day 0, I will attend the event 0. Okay, I will from now I will count them in zero index. So on day 1, I can attend the event 1, and on day 2, I can attend event 2, and on day 3, I can attend event 3. Okay. Yeah. So this being said, let me think of the algorithm. So in this case, the start date of the event is sorted already. And in that case, I think the optimal way to choose the event I should attend is I should choose the event which ends earliest. Otherwise, there is a possibility that I miss the event. So that's my intuition. So, okay, let me think with another example. So, okay. Okay, so in this case, on the first day, oh yeah, I think this is a good example. So on the first day, I should attend event 0. On the second day, I should attend event 1. And on the third day, I should attend event 2. So in this way, every day, I chose the event, available event, which ends the earliest. And if I choose to say on the first day, if I attend this one, rank 27 event, I lose an opportunity to attend the rank 26 event. And also, even if I attend the first rank 26 event of the first day, if I choose the rank 28 event of the day 2, I lose the opportunity to attend the rank 27 event. So that being said, I can say I should attend the event which is available on each day. And I mean, out of all the available event, I should attend the one which is the earliest. Okay, so then yeah, I can say I should greedily choose an event every day in this way. So I will count it. Okay. Okay, so the thing I should think of is so then so probably what I can do is for every day, if there's an event which starts on the day, so probably I can do it right. I 0. This is the index. I mean, count. Yeah, of the event. This is so I will push to the array of available events. So yeah, and I think I should use heap for this available event because what I'm expected to do is always choose the available event which ends earliest. And every day, I mean, it is possible the new event is dead, pushed. And yeah. So there is push operation, pop operation every day, maybe. And always I have to find the earliest end day, I mean smallest end day event. So yeah, definitely this should be, I should use the heap. Okay. So I should push the heap and then choose event and pop from event array and also increments the count. Then yeah. That's a thing. Okay. One thing I have to make it clear is how many days I have to do it. So yeah. Okay, so sorry. So yeah, because in this implementation, I have to iterate every day from days 0, 1, 2, 3 to yeah, many days. So but until which day I should do it? Maybe until the end of the maximum of the end date. Yeah, it is possible. However, if I do it, the time complexity would be, yeah, this max and day times because every event should be popped into the heap and also popped out of the heap. Yeah. So this is my concern. Yeah. Okay. So in this way, it should be the end date times the time complexity should be date times event count times logE, because every event is pushed into the heap and popped out of the heap. So in the worst case, so yeah, this is the loose bound of the upper bound. So heap can have up to E elements. Yeah. And in heap, it takes logE to push and pop from the heap of ranks E. So this is a time complexity. The page should be E because they have to, sorry, E for sorting. In Python, it uses a temp sort and it uses extra number of element space. And also heap should use, yeah, E space. So it should be O E. Yeah. Okay. I think I can optimize it in a way, especially if the run 40. So let me think. So Day 0, day 1, day 2, day 3, and to give a minute to think. So, okay, so the thing I'm thinking is how should I deal with the case like this? So, yeah. So in this case, I don't have to iterate these days, So, okay, I think one thing I can do is if the wait a minute, so wait, I think this implementation doesn't work because yeah, no, it works. I think so. Every day, if the start of the date, I will push it as a heap to and which means it means that it's already available, and of those available ones, I will pop it out. Yeah. Okay, so I think one optimization I can make is if there isn't any available event, I will change the date to the next event start date. Yeah. So with dips optimization, so the time complexity should be, E times log E, E log E, because I don't have to traverse all the days. I have to take care of only the every end day. Okay. The number of days I have to traverse in this for loop is 2 times E. I mean, every end of and the start of the event. So yeah, that's the thing. Yeah. Okay. Okay. So with this in my mind, let me do the implementation. Okay. So I will write the test. The first thing I have to take care is if there isn't any event, it will take, yeah, I can attend only 0. And also if there is only one event, I should attend only one. So these are very base cases. From here, I will think of some test cases, which is useful. So I think what I should check is two things. There are two things I have to check. So the first thing is, as I've shown here, it chooses the event greedily. So that's one thing I try to check. And also I try to confirm that there is a gap between events. It works fine. Yeah. With my optimization logic part. So let me write it down. So events are attended in a, how should I say, optimal way. That's why I check. So 1, 0, 0, and 0, 1, and 0, 2. Okay. So let me swap this because I try to confirm that the sorting algorithm works. Okay. I mean, it should internally sort it. So I try to check it also. So with this, number of event to be 3. And also, okay. So I will test it in this way. So I will check 4 and 5 and also 8 and 10 and also 0 to 0. In this case, there should be 3. Yeah. Okay. Oh, and let me just one more case because I haven't checked any test case where there duplicated event and they both of them one of them is skipped. So I will do it in 0, 0, and 1, 1, and also I will check 0, 1. So in this case, if I choose 0, 1, so I count and only one event. But if I choose 0, 0, and 1, 1, there are 2 events that I can't add. Yep. Okay, so let me do the implementation. So firstly, what I should do is sort the event. Then because I have to, pop up the event by the end date. I mean, the most prioritized event is the element is the one which has the earliest end date. So I will do it in this way. I mean, each element is a tuple. Okay. Okay, from here, I will start from day 0. Okay. And so I will also keep track of which event should be checked next in the event array. Yeah. So while there is any available event which has not been attended, or next event index is smaller than or equal to length of the events minus 1, I should do some operation. So the first thing I should do is I will append the event which starts on this day. So while then I will get the start date is equal to the state. So I will pop it out. Then I will append to the event. Yeah. So that's the first thing I should do. And also what I should do next is I should pop up the event which is available. However, the first thing I should do is pop out all the unavailable events. So while this is the first event start date, if no, end date. So if this is smaller than current date, I should pop it out. Yeah. All of these are outdated events, so we pop it out. Then what I should do is pop out an available event. Oh, that means event pop. So now I've got the first event, which is available. So I will attend it. So then, yeah, the last thing I should do is go to the next date. So what I should do is if length of variable is larger than 1, I should check the next date. And also if otherwise, I should check the next start day of the new event. So yeah. Okay, so otherwise, I will finish it. Then I will return counting. So one thing I'm wondering is, I have the same duplicate logic in line 69, line 81, 84. So let me think if I can simplify the logic for this while loop. So if there is a variable event, maybe I can change it to while true. Yeah. But in that case, so what happens if event is empty? I was just wondering. So yeah, I think I can just read it. Mm, yeah, okay. Ranks available event is, if there is, I should check the next day because it can be done on the next day. Okay. Yeah, I think I can make it to inventory. Okay, so let me go walk through this code. Let me change it. If okay. So let me quickly walk through this code. So let me check with this one if empty array is given. So this is sorted and finally get event is empty and count is 0, variable is empty, day is 0, and next event index is 0. Okay. So in line 70, rank event is 0. So this should be -1. So next event index 0 is not smaller than next or equal to -1. So I go to line 74. And rank variable is 0, so I go to line 77. And rank variable is 0, so I also go to line 81. Since rank variable is 0, I go to line 83. Next event index is 0, so which is not smaller than or equal to -1. So I go to line 86 and it breaks. Then I return count 0, so it passed. Okay, so the next case I will quickly check is if the input array is given 1, 2. So event is now only 1, 2, and count is 0, a variable is 0, empty array. Day is 0, next event index is 0. So in line 70, yeah, next event index is 0, and ranks event -1 is 0. So this is the first half is true. Then the latter half, next event index 0. So this is 1, which is not equal to 0. So this isn't true. So I go to line 74 and rank variable is 0. So I go to line 77, the same. I go to line 81. And because rank variable is 0, I go to line 83. And rank event is 1, -1 is 0. So yeah, in line 84, day is, I mean, event 0, 0, which is 1, the start day. So yeah. So now day is 1, and I go back to line 70. And now in the latter half, even next event index 0 is now equal to day 1. So I go to line 71 and I get, oh, start and end as 1, 2. Yeah. Oh, one thing I forgot to do is I have to increment this. Okay. Then I will push it into 2, 1, 2 variables. Okay. And in 175, length of variable is more than 0. However, the first element index 0 is now 2, which is not smaller than day, which is 1. So I go to line 78. And because length of variable is more than 0, so I pop it out from here. I get 2 and 1. So now I increment the count by 1. Then in line 82, length of variables is now 0. So I go to line 84. Next event index is 1, which is not smaller than or equal to 1 minus 1. So I go to line 87 and it breaks. And finally I will return 1. So okay, this pass. Okay. Actually, I'm pretty sure this code works now. The thing is, I've covered all the lines. I walked through all the lines and I was pretty sure of the logic. So yeah, I will run this code. Okay. Oh, good. The test passed. So I will run this code on the LeetCode platform. Okay, good. So yeah, all the tests passed. So I finished my today's coding practice. Okay, thank you so much. Bye.